take a look at section 1.3.1, identify mistakes involving the order of operations. Before we get into identifying the mistakes given a problem, let's take a look at let's just review the order of operations. So when we have the order of operations, or the reason we have it is, well, because when we have a math expression, that's an example of a math expression is this problem down here with many different operations to perform. And an operation is things like adding. There's nothing here, but this means multiplication, right? Next to the parentheses, subtraction, division, multiplication using the x symbol. We can see, and one example that's not on here is an exponent. Here I could show an example of that real quick. Say this is 2 to the, I don't know, fourth power here. That would be an exponent. So those are the different operations we see. So when we have a math expression with many different operations to perform, it is important that anyone who does it will get the same answer. All right, yeah, we don't want two different people doing the same expression and simplifying it and getting two different answers and being okay with that, right? For clarity, so that we all can be on the same page, we want to get the same answer. So because of this, hence, we have an agreed upon order in which to do these operations. Because if you did these in different orders, you could get different answers. Okay. So we have the order of operation steps. The steps we use to solve any mathematical expression are: 1. Simplify all of the parentheses, and more accurately, this includes all forms of grouping symbols, because we don't always use parentheses. Sometimes it's nice to use other symbols to show, so it's easier to read, because if you just use parentheses all the time and you have multiple sets of parentheses, it can get confusing to see what you're looking at. So we use things like brackets. I sometimes call them square brackets because the way they have the square corners there. And braces, these are a little curly, a little harder to draw. A brace, sometimes I call them curly brackets or something, but we use those in addition to parentheses. Step 2 would be to simplify all the exponents, right? And we talked about that before. An exponent is when you have something raised to a power, something like this. That means you write 3 multiplied 3 times. Another example would be, 4 to the second power. That means you multiply 4 2 times with itself. Okay. Step 3, simplify all multiplication and division. But remember, you got to go from left to right. So if you have a bunch of multiplication and division, you do whatever is to the left first, and then you work your way to your right. So it doesn't matter if it's multiplication or division, whichever one's farthest to the left. If you have both of them going on, do that one first, and then save the ones to the right later. Just kind of like you're reading from left to right. And the last step is similar to that, but it's addition and subtraction. Again, if you have a bunch of it going on, work from left to right, because there are certain circumstances where it can make a difference if you do not follow that. And if you follow all these steps in order, we can solve all problems and anybody can get the same solution. Sometimes they refer to math as the universal language, because it doesn't matter which language you're speaking, these orders follow through to everyone. All right, so here's an example problem. We still haven't gotten to what the IXL problems will look like, where I have a multi-step expression, lots of different things going on here. And off to the side, we've got just a little quick, preview of what the order of operations is. We've got this mnemonic device, PEMDAS, so it's a made-up word, but each letter stands for something. P is parentheses or any grouping symbols. E is for exponents. M is before D in this word, but just know that M and D are at the same level, multiply and divide from left to right. And AS is also together for the last step, add and subtract from left to right. So here's a problem. Let's make sure we do this correctly by following the order of operations. So let's start off with this problem. And first we do stuff inside the parentheses. And we have two sets of grouping symbols. We have the parentheses, and we also have these square brackets. So when you have more than one set of grouping symbols, do the ones on the inside first. So those green parentheses that I did. And inside here, we have to do order of operations as well. So we have addition and subtraction. So they're on the same line. They're at the same level over here. We do it from left to right. So the farther left one is 11 plus 1. So everything else gets rewritten. And 11 plus 1 equals 12. And we still have the minus 4, the curved parentheses, the square bracket, divide by 2 to the third power times 2. Okay. Now, still inside those parentheses, but now it's a subtraction, 12 minus 4. And that's going to equal 8. And sometimes you can do more than one step at a time, but in this example, I'm going to do only one step for every line. Okay, we still have grouping symbols. Now, it's important to note that this right here, there is an absence of a symbol, right? There's no symbol there. That means multiplication. So if you want to, you can put a little dot there if you'd like to. But yeah, 6 parentheses 8 means 6 times 8. And that's what we do because it's inside the parentheses, and that's going to equal 48. So now it's 3 plus, and I'm going to get rid of all the grouping symbols at this point because now all of that stuff end up equaling 48 divided by 2 to the third power times 2. So technically now it took us a couple steps, but we have now finished the parentheses step, right, and the grouping symbols. We got rid of all of them because we did the operations inside those first. Okay, now let's check. Are there any exponents? And I do see an exponent here. Okay, 2 to the third power. That means 2 times 2 times 2. And that equals 8, right? So plus 48. It's still divide here, and that's going to become an 8. Okay, no more exponents there, so I'll cross that off. Exponents are done. Now I should be looking for multiplying and dividing. If I have 2 of them, I should do the leftmost thing first, and I do have 2, right? We've got division and multiplication. Make sure we're going to have to do the division first because it's farther to the left. So 48 divided by 8, and that equals 6. So we still have this 3. This 3's been kind of with us the whole way through. 48 divided by 8 is 6, then times 2. As we said before, we're going to have to do the multiplying next. So 6 times 2, that equals 12. And the very last step, we finally get to use that 3, and it's 3 plus 12 is 15. There's no more steps to do, so that is our final answer, 15. And again, you could sometimes do more than one step at a time. I chose to do this just doing one little step at a time. That's a nice way to make sure you're staying organized and not getting confused with multiple steps. All right, let's take a look at a level 1 type problem here. So here's Leroy's work. Leroy tried to evaluate an expression. Here's his work. And maybe this is kind of a separation right here. And then we have 3 possible answers. So you can see it's clear that he did this in 6 steps. So he going from the first step, or from the original to the first step. Notice the things that, try to look for things that have changed. Well, maybe I'll underline the stuff that looks like it's the exact same in yellow. How about? Yep, all this. And it looks like, so that means Leroy took this stuff I'm underlining in green and made it into a 6 to the second power. And so it looks like to go from 4 and 2 to 6, that's adding, right? 4 plus 2 is 6. And so he did not do the right order. The first thing he should have done here, maybe think about that. So yeah, maybe take a look at this and just for a second think what should have he done first? Think about that, the order of operations. And yeah, if you're looking at this, you would be first thinking parentheses, but there are no parentheses. So he should have done the exponents. So he should have done 4 to the second power and 2 to the second power before any addition. So I can see he is not correct. So we don't have to pick that last one. So which option is the best? No, Leroy made a mistake going from the given expression to step 1. Okay, this sounds good. Leroy should have squared 4 and 2 instead of adding. Okay, yeah, that is our correct answer. So it's this option. Okay. So we can reason through it that way. All right, let's take a look at another one. So here's Tisha's work. Tisha tried to evaluate an expression. Here is her work. So remember, these are the orders. This is the order, I mean. Maybe take a minute to see if you think she did this in the correct order. Let's take a look at this. So again, from what stuck around from the previous problem, the timesing by 9 and then the minus 2 times 3, the 490 stayed. So it looks like the thing that changed was right in here. And it looks like they squared 7 or raised 7 to the second power. And that's not the very first thing, but that's okay because there were no parentheses or grouping symbols. So far, step 1 looks pretty good to me. Okay, now what stays the same on this next level? So the 2 times 3 is still there at the end. And it looks like the 9 was there as well, actually. Yeah, the 9. But the thing that changed here is this 10. Where did this 10 come from? They must have gotten that from dividing. Was that a good first move? So we move along from exponents. Next was either multiplication or division, and they did divide, and it's farther to the left. So I think, yeah, I think step 2 was good as well. 490 divided by 49, they calculated that correctly. That is 10. Okay, let's take a look at the next line. So the next thing is I see that the 2 times 3, it's still there, okay? But the 10 times 9 became 90. So they multiplied, and that's okay because they had either multiplication to do. There's 2 different multiplications and there's subtraction. They did the multiplication on the left, so that's good. So next they should be doing the multiplication on the right, and it looks like, oh, they did not do that, right? Because 2 times 3 should be 6, and they still have a 3 there. It looks like they subtracted before they multiplied. So we have to find the option that identifies the mistake here going from step 3 to step 4. Okay, so it looks like it's the middle one here. So the correct answer in this case is no. Tisha made a mistake going from step 3 to step 4. Tisha should have multiplied 2 and 3 before subtracting. Yep, good. Let's take a look at a level 2 problem. Kimi. So let's take a look at Kimi's work. So now we've got grouping symbols at level 2, you can see. So they were early on, Kimi should be working on stuff inside the parentheses. Let's just make sure that happened. So I see this is the innermost, 9 minus 5, and that becomes 4. It looks like Kimi did that good. Everything else stayed the same. So step 1 looks good to me. Next was the stuff inside inside here. And inside here, there's two things going on. Inside these square brackets, there's subtraction and there's an exponent. Exponents come before subtraction, right? Exponents are earlier on, subtraction is later. So that was good that they did the exponent, because 4 to the second power does equal 16, because 4 times 4. Okay. Take a look at the next step, see if they did the right thing. Going from step 2 to step 3. It looks like to me, I see that this part is gone, and now it became a 5, right? This ended up equaling 5, and that is what 21 minus 16 is. And that is still grouping symbols. So we're still doing the very first thing. That's good. Okay. And now we're at a stage where there are no grouping symbols anymore. So we are done with the parentheses. And I don't see any exponents anymore, so we're done with that. So now we're either looking at multiplication and division. Remember, they should be doing that with the leftmost first. So ask yourself, did they do that going from step 3 to step 4? Did they multiply? And it's kind of tricky here, because multiplying 3 times 5 is 15. And I see a 15, so you might think, oh yeah, they did it correctly. But be careful, the 18 is gone as well. I think what they did is they took 18 minus 3 and got 15 that way. And then see how this times 5 is still there. So this is actually a mistake. They should have kept the 18 and the minus sign. They should have multiplied first at that stage. So yeah, there's a mistake there, going from step 3 to step 4. And that would be this middle option, right? Yep, Kimi should have multiplied 3 and 5 before subtracting. Okay, let's take a look at another one. Bridget's work here. So we're looking at this order. So she should be doing something with inside the parentheses first. So everything inside the parentheses. And then there's a couple things going on in there. There's addition, there's multiplication, there's an exponent. Which of those should be done first? And then, did she do it correctly? Well, inside of all those things, exponents come before multiplying or adding, and 2 to the second power is 4. And it looks like she did that correctly. Awesome. So now we're still working inside here, but now we've got either adding or multiplying. Think about which one should be first there. And then looking down here, did she do that correctly? Looks like she multiplied. And that's okay, because multiplying does come before addition, so that's good. We still haven't gotten rid of the parentheses. They're still there. So we have to still work. That's still the stuff we have to take care of. So the stuff inside there. And 1 plus 12 is 13. That looks good. Okay. Next, now it's really simple. We just have division and subtraction. Think about which one of those should be done first. And hopefully you thought division, right? Division does come before subtraction. So dividing, and is that what they did? Well, the 13 still there, so they must not have subtracted, and 66 divided by 3 is 22. That does equal 22, so that's good. And then at this point, really, I mean, there's only one step to do. So 22 minus 13, and they did do that. So I think Bridget was correct on this one. Yeah, awesome. So you can get answers where they did do it correctly, but I would just make sure you're analyzing it very carefully like we did here. And now you won't need to do level 3 problems, but I'd like to go over one of these as well. So this is Reba's work. So let's see here. Okay, let me rewrite the PEMDAS word. And we're looking first, of course. And I see some grouping symbols, so we got to make sure that they did that correctly. So there's 2 sets of grouping symbols here. Let's see, they've got the square brackets, and they've got the parentheses. Okay. And between those two, think about which set should we do first? The stuff inside the yellow or the stuff inside the red? And hopefully you thought the stuff inside the red, right? We always do the innermost first when we come with grouping symbols, and then we kind of work our way to the outer stuff. So the innermost is just 1 plus 2, which is 3. Now, I think we have a problem, though, because I don't see 3 anywhere down here. If you're taking a guess on what they did, it looks like to me, they got a 4 here. So I'm guessing what they did is they took 2 to the second power, because 2 times 2 is 4. So I think that's the mistake that was made. But regardless, I know that a mistake was made in step 1. So yeah, this was wrong, right? Because 1 plus 2 should equal 3. So technically it should have been 3, and the exponent of 2 would have still been there. And they would have gone from there. So let's see. It looks like, yeah, let's see. No, Reba made a mistake going from the given expression. Yeah, so the given expression is the original problem to step 1. I think this is correct because Reba should have added 1 and 2 before evaluating the exponent. Correct. Yep, that's our answer.